Hello, happy Wednesday.
Hi.
Hi, y'all. I know it's probably not Wednesday when you're watching this, but it is Wednesday when we're recording this. And
Yep.
you will learn about Mr. Bobby. Um, I like to I wear
He's
pink
a he's a mean girl at heart, is what he's about to tell you.
because on Wednesdays we wear pink.
Yep.
Anyways, the good thing is I think we're meeting on Tuesdays when we have a face-to-face meeting, so you won't truly get that experience, but you will get it in October. One of the things that I do in my family, um, some people in my family have a history of breast cancer, so it's very important to me. So yes, there's a reason for why I'm wearing pink. Anyway, so we're going to record the video here about solving linear equations and solving linear inequalities. We kind of condense some of the chapter one. They'll spread out a little more when we get to chapter two. So let's jump on in. So some of this isn't going to be earth shattering to you, but we're going to go through and make sure that everybody's cool. And because it's Wednesday, I will wear pink. We want to solve, or I'm going to write in pink. We want to solve this equation. And when we see parentheses, what did we say the parentheses meant the other night? It meant yesterday. Distribute or multiply. So I'm going to distribute that 4. I don't need to do anything on the left side. But I do need to distribute. That would give me 4x, but everything in that parentheses gets multiplied, so it'd be 4x minus 4. Okay? Then our next purpose is, of course, we want to make sure all the variables on one side and all the numbers on the other. It doesn't really matter. So I'm going to be awkward and make you mad. I'm going to subtract the 3x.
He's choosing the 3x right now to try to keep the coefficient, which is the number that's attached to x, from being negative. If you wanted to subtract the 4x instead, that'd be perfectly fine. You would just end up with negative 1x.
And there are a lot of people who are teachers who like to have all the variables on the left side. We don't, I mean, I think you maybe picked up already, we don't necessarily care, but it's all good. And if I'd done that, I would have ended up with negative x, and that's all good. You would have maybe had to do a different step. And then I've now successfully moved the variables to one side, and I can now finish by adding the 4. We want to do the inverse operation to get it off of that side of the equation. So the opposite of subtracting 4 is adding 4. And the nice, wonderful thing about this problem is it ended up with x. I don't have to do any extra math at the end. And if I can do math right, 7 and 4 make 11. Okay?
And you can check, remember, any equation by taking that answer of 11 and plugging it back into all the x's in the problem and making sure that you really do get a true equal statement. So in this case, on the left side, that would be 7 plus 33, which is 40. And on the right side, that would be 11 minus 1, which is 10, times 4, which is also 40. So remember, you can always check an equation by plugging your answer back into every x in the problem and making sure you end up with the true statement.
You can't sit with us. You're writing in pink.
I'm writing in purple.
Or purple, I mean, yeah, that's what I said. I don't know my colors. Okay. And now I have a dilemma. Do I clear the ink first or do I advance the slide first? Do you have a preference? I guess it doesn't.
I don't have a preference.
Okay. All right. So we're going to move the floating heads around a little bit so that we're not in the way of the text again. We would have been in the way of the second problem. So a couple of things that watch out for. I know maybe you're like, oh gosh, this is easy stuff. One thing that we really want, everybody hates fractions. And if there's fractions in an equation, there's an easy way to to make the problem simpler, is if we multiply both sides by the common denominator, poof, the magical fractions are gone. So, oops, and let me back up here and grab my pen. So in pink, what's the common denominator 2 and 4? Well, it's 4. So I'm going to multiply this side by 4. But what I do to one side, I must do unto the other. That's like,
and multiplication is like division. If you're going to multiply on the left side, everything gets multiplied, not just the one thing. So when you're adding or subtracting on both sides of the equation, you're looking for like terms. But when you're multiplying and dividing, you're going to multiply everything on that side by that number. So what he just did right now is distribute this 4. He said 4 times a half, that's 2, because half of 4 is 2. And then 4 times negative 6 is negative 24. Then he did the same thing on this side, right-hand distribution. 4 times 3/4 would be 3. And 4 times -9 would be -36.
Can I distribute backwards like that? Is that okay?
I said it's right-hand distribution. It's fine.
Okay, all right, just checking. I mean, I don't, it doesn't look like the way my other algebra teacher did it, but it's the same thing, right? Multiplication can go back
Yep.
and forth, okay?
Definitely a commutative property.
And if I did this problem, like maybe some of you might have wanted me to do the previous one, when I do the subtraction of this, then I'm going to get negative x. And you need to remember that there's an implied 1 there, so it's really like -1 times x, which is why I kind of moved it over. If I have a little choice and a little foresight, I try to move the smaller x term to the side with the bigger coefficient x term, so I don't have to worry about a negative. But you do you, okay? Oh, that's supposed to be a 2. Pretend that's a 2. First mistake tonight, right?
Well, and then followed by the next mistake. Make sure when you're pulling down your terms, you're paying attention to signs in front of the number. So, yep, that's a -36.
There was no mistake. You don't have any evidence of that. So I end up with -1. And actually, this is actually a prime example of why I try to bring avoid a negative on the x, because I'm going to, the more negatives I have, the more likely this guy's going to mess up. Okay. What is that? -12? Am I okay now without any?
I think so.
All right. And then if I divide by -1 and divide by -1. Now, this begs the question. How much of this do you have to show for us on a quiz or a test? Could I have just gone, like, did I really have to show this -1 division on both sides? Or do I think you're smart enough to know that if they're both negative, we're going to drop the signs? I'm okay with that. I would like to definitely see some steps about the multiplication. I would, but you might be able to do some arithmetic in your head. We're going to give you that. But when you start skipping steps, and I was going a little too fast there, that's when I almost missed the sign. Now, I'm lucky that I have somebody with a master's degree in math watching me do these problems as I'm doing it. But when you, as a high school junior or senior or whatever grade you're in, are doing this in the privacy of your home while you're working on your homework, you don't have that luxury. And more importantly, you don't have that luxury on a quiz or a test. So slow that roll and take your time. Okay, you ain't going nowhere. Yep. Take your time and do it.
And guys,
with negatives.
Yeah, and guys, really and truly check your answer, because you're gonna make mistakes. Like, it's going to happen. So take your 12, plug it in. Half of 12 is 6. 6 minus 6, 0. 3/4 of 12 is 9, and 9 minus 9 is 0. So it checks out. Plug it back in and check your work. Okay, Mr. Bobby, he's moved on ahead of me.
I moved on ahead of you to get a head start because I can't write as fast as Miss Young talks. The only thing I asked about this problem, one caution about this problem, is when you have to distribute. If you have to distribute a negative, slow down. And I'm sorry. So notice I circled the -6. I didn't necessarily, I could have done that for the 3 and done that, but I'm okay-ish with a positive number. But when I have to distribute a negative, I stop and look real careful, okay? So -6 times 4, you're writing on underneath your face.
Oh, okay. My bad. Did you move me?
Now I moved you so you can write.
Okay.
Under your face.
I want to bring up one more point too, because every single time I assign a problem like this, or I put a test question on like this, somebody inevitably will say, well, I'm just going to subtract 4 minus 6, and that's going to give me -2, okay? So please remember order of operations. Please excuse my dear Aunt Sally, or as I learned from a New Jersey teacher, please execute my dear Aunt Sally, and make sure you do this distributive property multiplication before you subtract. This is a big no-no. That's always going to get you the wrong answer.
Yeah. And I'll slap your wrist on a quiz or a test. And I don't think you want that. I want you to get a good grade. We actually kind of like giving good grades, but you got to earn them. Okay. Yep. And then from this point on, I'm good, right? Y'all really want me to solve this? What do we get?
Yeah, solve problems. We haven't done anywhere they have to combine like terms on one side and whatnot.
That's it. 12x minus 3 what happens on the right side? The 4 and 18 become 22?
Yep, so what he's doing here is on this right side, he's got like terms. So +4, +18 coming together for 22. And he wrote that first. That's perfectly fine. He could have written the 22 after the -6x. It doesn't matter. Order doesn't matter. We do want to make sure that when he writes the 6x that he writes -6x and brings that sign with it.
So I'm going to add 6x to both sides.
So remember, he's choosing the x value that has the smaller coefficient. So -6 is smaller than 12. So that's the one he's moving.
And if I'm in the interest of time, I can do 2 steps at one, and you might be able to if you're organized as well.
Yeah.
I know that I'm okay with that too.
Yep. So what he was thinking is if I'm going to get rid of the x's on the right side of the equation, then I want to get rid of the constant or the number without x's on the left side.
And what do I get? 25 over 18?
As your final answer?
Yeah.
Yep. I'm not going to plug that one in for you in my head because yuck. This is one where I would recommend using your calculator to check each side of the equation to make sure you get an equal statement.
Okay. Fair enough. So
beautiful, beautiful. Look, your handwriting is so much better than yesterday.
Yeah, I'm getting better. Yay! All right, and I have to go a little slower, but and I have to clear that doesn't really help me. Okay. All right, folks, we were new to this too. We were using some technology, doing it differently than we have ever done before. So we will get better, but and we may end up re-recording the first video at some point and then be like, what are they talking about? So anyway, all right. So we have 3 weird conditions in Algebra 1 or whatever. Maybe you did this. Everything worked. Everything was beautiful. Everything was nice. You didn't get any 25/18ths. This is college algebra. We're going to make things a little ickier and a little harder at times, of course. And so if you get a number like 25/18ths, it doesn't mean you're wrong. You might just be being mean. That's what I do. But you also are going to get 3 weird cases, and maybe you haven't really talked about this before. You can either get what can happen when you solve an equation. There's sometimes I can tell you something that is the case right now. So like right now, it's sunny outside. Okay. Yesterday it was rainy outside. That's a unique situation. I can give you, it only happens at certain times. So there are examples like this. If I were to solve this, I would get 2x. Oops, maybe I should go back to the, get my pen. I would get, let's see here, 2x equals 12. And I'm not showing all my steps now. And when I do that, I would get x equals 6. And that's beautiful, glorious. I'm happy. I know there's a unique solution, okay? That happens a lot, but it doesn't always happen in college algebra because some funny business happens. And when I were to do this problem down here, 2x plus 5, and on the right side, when I combine like terms, I'm going to get 2x plus 5. And if my next step would be, let's see here, to add those, to subtract 2x, what would I get in my next step? I would get.
So what he's saying right now is he's got x's on both sides of the equation, and we've just solved a lot of problems with x's on both sides of the equation where we told you to go ahead and move that smaller one. We got 2 and you got 2. So when you go to subtract one of them, you subtract 2x from both sides, x is completely gone from the problem. That's not necessarily a bad thing. You just have to know what it means with what's left over. So in this case, what's left over is 5 equals 5. Go ahead, sorry.
Okay, and what that means, if that happens in the course of you solving a problem, that means that statement, the original equation, was actually what's called an identity, and it is always true. It's a claim that is always true regardless of any x value. It is always true that I have amazing fashion sense, regardless of, my shoes are spectacular at all times, all right?
And also, so like if we could pick a number right now, like 1, and plug it in, we would get 2 plus 5 is equal to 5 minus 3 plus 5, which is true. We could also plug in 5 and get 10 plus 5 is equal to 25 minus 15 plus 5. He's telling you that we could literally plug in any real X number, and this equation is going to be true.
Okay, so it's always true. That means it's an identity. Now, when we get one that is inconsistent, what happens if it's going to work out the same similar way? I'll get 3x equals 3x plus 4 when I combine the like terms. And when I go to subtract the 3x, what I'm going to get is 0 equals to 4. And that makes me sad. And that's false. That's a case that is never going to be. You can pick any number. There is no number that we can put into there using Ms. Young's language. There's no number that I can put in for x that's ever going to make that true. So that's a statement that's always wrong. And I won't make I won't make fun of Miss Young. So, unless you want to make fun of me, but that's okay.
No, you're trying to say that I don't have fashion sense, though.
I wasn't going to say that. I wasn't going to say that. I just wasn't going to say that. Okay. So, okay. Moving on. And let me clear my ink again. All right, so of course there's the obligatory word problem because Ms. Young made me put in an application problem.
So we're clear. What I said is maybe we can talk about how this is relevant to real life, like I always talk about.
Yes, and we both really like to see math in real world. And I'll tell you, a lot of these word problems in the textbooks are contrived, and they make great memes. Okay.
True.
And honestly, you might be able to figure this out ahead of time, but if we read through the problem, in the 2012-2013 school year, there are 47,058 U.S. students studying abroad in Italy and in France. There were 12,638 more students studying in Italy than in France. Find the number of U.S. students studying abroad in each country. So what we have to figure out, and some problems you might be able to figure out in your head, I'm not sure I can figure this one out in my head. I mean, like the ones that you might have seen in 8th grade, y'all are really smart folks, and sometimes you can argue your way through them. But I made the numbers icky here, so I just can't do this one just in my head. I might be able to if I sat down, but I can't just stumble on this answer. So what I need to do is figure out, there's two countries that I don't know how many students are in each, but I do know that there are more students studying in Italy. So I'm going to pick one of them to be the variable. And it seems like since I know something about Italy, I don't know anything about France. And in math, when you don't know something, what does it become?
The variable.
So I'm going to let X be France. Okay. Oh my gosh, have you ever seen the Saturday Night Live skit about Jerry Seinfeld in the social studies classroom? Oh,
Yeah.
Yes, you have. I really want to watch that video now. Guys, who don't, just Google Jerry Seinfeld, Saturday Night Live, social studies classroom, and you'll know what I'm talking about.
Yes.
But if France is X, then we know there are more students studying in Italy. How many more students are there? Ms. Young, go ahead and underline where you think, what do we know about Italy?
Let's see, what did we just say? There's 47,000 in Italy.
Yeah, how many more? Yeah, that's how many. That's how
and
many.
In France.
Italy and France, but how many?
Okay, sorry.
What's our total?
There's 12,638,000 more students in Italy than there are in France.
So do I let that equal Italy?
I don't think that's how many people are in Italy. I think it's.
Either. But
I think that's how much more there are.
More than what?
More than France.
More than France. So what is France? France is X. So I'm going to take that number that we just had and combine it with the people that are in France.
And for those following along right now, I tend to not use X in problems like this. I probably would have said F equals France, and then France plus 12,638 would be Italy. So if you like your variable to match what's happening in the problem, you use whatever letter you want. You can even use the word France.
I could. Okay. Why don't we use Francis? Because you would be here forever watching me write the word France.
Right.
Okay. So if I used F, it would be, so I'm just going to combine X plus the 12, whatever the number is. Was it 12, 638 plus X equals the total. Okay.
So here's what just happened, and this is why I like to use the words, letters with words. This X would be France. This 12,638 would be Italy. So what he just said is France plus Italy has to be that 47,058 number. Then he's combining like terms.
And I got to solve this. Do you know what 47 something something minus something something is?
I got a phone.
Yeah,
I
let's
can figure that out. You ready?
I could do that.
47058 minus 1 2. What is that? 638 34.
It's like 34.
34, comma 420.
Okay, and now what I have to do next is divide that number 34420 divided by 2.
Yep.
And
And 34 divided by 2 is 17, and 420 divided by 2 is 210. So 17, 210.
210. Now that's half my answer. Okay, and if you, I don't know if you run into this in the ACT. I could see if this problem were like an ACT problem, they probably might ask you, the question would be, what's the total population, or what's the population of students going to Italy?
Yes.
I have just answered the first part. France has 17,210, and Italy would have like 29,000 something. Was it 20,000?
So to find Italy, we would then take that 12,000 and add it to the France. So I would take this 17,210 plus 12638, and that would give me 29848. Yep.
Okay. So that's Italy, and this number down here is France. France? Okay. Okay, anyway, I can't spell today. There we go. All right, love the lag of Zoom. All right, so, and I'm not going to give you a problem on a quiz or a test that you're just going to be able to pop out in your head. You're going to have to do some kind of argumentation, okay? So count on it. All right, ready to move on?
Let's do it.
Let's do it. I'm going to clear because it looks awkward when I move. Okay, ooh, I like these questions. Okay, so what did we do before when we had fractions?
We multiply by the common denominator.
Yeah, but the denominator's got x's. That's icky.
That's okay. We can still multiply by the common denominator.
Yes, we can. Yes, we can. So what I'm going to do is the common denominator is x plus 2. All right. So I'm going to do x plus 2, and I'm going to treat that. Oh, it's not plus, it's minus. Silly Mr. Bobby. I caught my own mistake. That's pretty cool.
I'm proud of you.
You know, first time I caught my own mistake. And then I'm going to take this thing times x minus 2. Now, I could maybe do it without the parentheses, but I like to have it there so I have the visual. I'm going to take this entity of x minus 2 and multiply it by the first fraction. And that looks really icky, but the beautiful thing is I have x minus 2 on the top and x minus 2 on the bottom because this is kind of like over 1. And that means the x minus 2's on the top and the bottom divide away, and all that I'm going to be left with is a big old 4.
Another way to think about it is right here you've got this multiplication by x minus 2, and right here you've got division by x minus 2. And we know that multiplication and division are inverse operations.
And they go bye-bye.
Yep. And that leaves you with that numerator 4.
So then I would have to do 3 times that parenthesis, and that's why I put the 8 parentheses in there. to make my life a little better. And then what happens on the right side is that the x minus 2 and the x minus 2 divide away. And what will I be left with on the right side? Just the x. And look, I had what was an awful problem, awful looking problem, looking like one of the easier ones that we did earlier. Okay? And I'm going to go ahead and then solve the problem from here in the interest of completeness. Let's see, what that would be 3x minus 6.
Yup.
And let's see here. So what would I have? Negative 2.
So he's combining 4 and negative 6 right now.
And that would equal negative 2x.
He's skipping steps on you guys.
Oh, no.
He also at the same time subtracted 3x from both sides. I know, college class, not high school class.
X equals 1.
So divided by negative 2.
And got x equals 1. I would like you to pause the video now and do the problem.
Wait, before you pause the video.
Okay, sorry.
In these problems, it's so important to check your work. Do we want to talk about when it doesn't work?
That's why they were about to figure that out. You blew it. You ruined it.
Do the next problem.
Pause it. Now you're getting to see us fight each other. Pause and do the next problem. Resume back if you haven't already, but if you were...
I really hope you paused the video and tried.
Yeah.
I really hope.
Yeah, when we asked you to do that, okay? And you know what? I just thought of something. You might be watching this on double speed, so if I sound like Mickey Mouse, that's okay. Do any of y'all do that? Do you do that? Like listen to...
I always do that.
Okay. Yeah.
I think I just I don't know, but I can't. I always speed up people.
Okay, whatever. But yeah, we do that and we multiply, we move this through. But in this problem on the right side, you're going to multiply by y minus 3, and you probably ended up with this. Oh, let me get my marker back. So I'm going to end up with y, let's see here. And then I ended up, after I multiply, and she's going to maybe go ahead and do the... I'm not showing all this because you, of course, did this on without pausing. While you were paused. And then when I work this out, you get y equals 3, I think. And again, college class. Okay? Because I would have gotten, when I distributed here, I would have gotten 3y minus 9, and that would have given me 4y and 12. And it gives me 3. And if you stop now and put a box around it, I'm going to take points away from you. Now you can tell your story, Miss Young.
So previously in the slides, I told you not to solve a problem without checking your work. And now it really matters, because if you've been watching these videos in order, you know that you can't divide by 0 because we already told you not to. We already said, if you divide by 0, it's sad, like taking cookies away or something. So you're going to plug your answer in, and you're going to get 3 divided by 0 plus 3 on the left side. And on the right side, you're going to get 3 divided by 0. But it doesn't matter, because the first time you see a divided by 0, you're going to stop. And you're going to think to yourself, wait, that's sad. And that means, in this case, y can't be 3. And there are no solutions to this problem. So what did we call that in the previous slide when there were no solutions to a problem?
No, you're asking me to remember something I did already? Or something taught me? What did we call that?
What did we Inconsistent.
Yeah, so this is college and we're all sophisticated. So we would not, I mean, if you said no solution, I probably wouldn't have a connection, but this is inconsistent, if I can be consistent with my marker. So
while he's attempting to write inconsistent, I can't say it enough times in this presentation here that you need to check your work. Once you get out of high school math, your professors are going to throw questions at you that don't work just to make sure that you're verifying your work.
Okay? Okay, thank you very much. Okay, so let's move on. I think we're done with equations. Let's move on to inequalities. And solving inequalities have the hungry alligator. Okay. Was that an alligator or was it Pac-Man?
No, it's definitely an alligator.
An alligator. Like there was a phase when Pac-Man, I guess it was the age. I don't know. I'm showing my age. Shut up. Everybody loves Pac-Man. Okay. So if A is greater than B, then A plus B is greater than B plus C. And if A is greater than B, then and C is greater than 0, then AC is greater than BC. And if A is greater than B and C is less than 0, then AC is less than BC. I should have actually had the other cases where the inequalities are reversed. And you're already sick of me talking. Miss Young, tell them what this means.
So I'm actually not going to go line by line here. You can add or subtract on either side of an inequality. Treat it just like an equation. You can multiply and divide on either side of the inequality. Treat it just like an equation. But there is one thing you must remember. If you are multiplying or dividing by a negative number, multiplying or dividing by a negative number, you must switch the sign. So if it's less than, it becomes greater than, and if it's greater than, it becomes less than. Let's work a problem.
Let's do the problem. So you said I could add or subtract without any penalties, so I'm going to do that. I'm going to subtract 5. And I get negative 2x is greater than or equal to 4. And then I want to divide by negative 2. Radar goes up, negative. When I do this, I have to switch the sign. So I would now, instead of it being greater than, it becomes less than, negative 2. Okay?
And if I were going to explain that to somebody, it's kind of a tough one to explain why that happens. But if you think about a number line, if I'm pointing to the left, I'm on the negative side, I'm pointing to the left, and then I switch from negative to positive, I'm now pointing the other direction, right? So if we change that sign, we have to change what direction it's pointing. And it's all, the number line is a crazy thing. You have to remember there's 2 sides to it. So that's kind of a simple explanation as to why that inequality flips when you multiply or divide by a negative.
Yep. It makes sense to me, but I also have a master's in math. So, but it has to do with the order. The numbers, like I kind of think of the numbers as reversed on either side, even though they're still logical. Because negative 2 is less than negative 1, but 2 is greater than 1, and that's kind of that flippy flop thing. So, okay. So basically, if you can solve an equation, you can solve an inequality if you can remember the one difference. And that works if I had multiplied by negative 2 on both sides, or multiplied by like negative 1/4 or something. So
yeah.
Okay. All right. So what about this guy? How you want to do this one?
How about we work it just like there was an equal sign?
Yeah. All right. What do you want me to do with my first step?
So I'm tempted to tell you to subtract 2x from each side because it's the smaller x and that's the rule I like to live by. But let's subtract 4x because that's the one that might trip kids up.
Yeah, and many of you were taught to bring the variables to the left side, so you might instinctively do this. Okay, and that's okay. I'm still going to be able to get the problem, but get the answer, but I'm now introducing a negative number here. So I'm going to get negative 2x minus 3. Now, if you are, math savvy, like, math savant, you might have subtracted 2x and, oh, wow, I don't have to worry about the flip-a-roo thing. But we'll talk about that. Maybe talk about that later. So I want to add 3 to both sides. And so I get negative 2x is what? 8? Less than 8. And when I divide by negative 2, I'm not skipping steps because I'll get yelled at again. Well, and I don't want to, again, when I'm dealing with negatives or dealing with inequalities, I'm a little more cautious because I know I'm going to have to worry about some things. x is now going to be greater than -4.
So, Mr. Bobby, I actually think this is a good time. Let's go ahead and work this problem both ways because the answer is going to look a little different, but I want to be clear with students that because of what side of the inequality X is on, the inequality could look different, but that doesn't mean the answer is different. So if you had used that method of subtracting the smaller variable, you would have subtracted 2x and gotten -3 is less than 2x plus 5. Then you would have subtracted 5 and gotten -8 is less than 2x. And you would have subtracted 2 and gotten -4 is less than x.
Well, you might have divided by negative.
Oh, I don't know what I said. Sorry. You might have divided by 2, I hope.
It would have been wrong, but it
Sorry. And getting -4 is less than x. So
this is wonderful having two teachers as we catch each other's mistakes.
yeah.
Okay, how is this the same as this?
So when we read an inequality where there's a variable in it, we always read from the variable, okay? So if I'm reading the first one, I'm reading x is greater than -4 because I'm reading from x. And if I'm not careful on this one, I might say -4 is less than x, which is a true statement, but I want to think about it from the variable x is greater than -4. It also might be a good moment to just remind you that if I'm going to graph this on a number line, and I'm going to be lazy here, I put my -4 here. I get my open circle because it's not equal to that. It's only every number greater than that -4. And then I would be talking about every number that's bigger than -4. This is saying the exact same thing, okay? It's saying that -4 is going to be less than every single one of your answers. And if -4 is less than every single one of your answers, then your answers are all bigger than -4.
And I would just put it a little simpler, maybe not, put it like an elementary school teacher. The hungry alligator prefers X in both of those.
Yeah.
So not that what her beautiful explanation was wrong, but
maybe too many words. I'm sorry.
that's okay. All right, so let's clear that out and move on. If I can advance without breaking myself. Oh, that was wrong. There we go. All right, last piece is what's called compound inequalities. These are two inequalities that are joined with and, or the words and or. If something is or, if I give you the choice of cleaning the bathroom or the kitchen, you don't have to do both. You can do one or the other. You could do both. That would be great. I'd love it if you come over and clean both my bathroom and kitchen. But if I gave you the explicit instruction of doing the bathroom or the kitchen, I should only expect one of those two things to be true. If I say to do both, you must do, if I say you got to clean the bathroom and the kitchen, you have to do both, okay? So I want to find in this solution an inequality and that will satisfy one or the other. So I'm going to try to solve the 3x minus 7 equals, and you can try to do the other one if you want.
Hey, let's save time. So we'll just quickly, whoa.
Oh, I didn't pick up my pen again. All right, how do we save time?
He's gonna work the left one, I'm gonna work the right one, and then we'll talk about it. Are we racing? Because it might be fun if we race.
I don't think that would be fun at all because
you might beat me.
I don't know. Do I have to show my work?
I'm showing my work. I really wish that I had an iPad to write on. Hey, I made a mistake.
Your first mistake ever?
No, unlike you, I make tons of mistakes, and I just hit clear instead of undo, so that's cool. Talk about yours, Mr. Bobby, while I rewrite all of mine.
Okay, you could have done redo.
Oh, I could have.
Uh-huh. That's okay, I'm going to rewrite my... Did I do the problem right? I added 7 to both sides and got 21. When I divided by 3, I didn't have to flip the sign, so I get x is greater than 7, or if you can read, it looks like x greater than. Like x is really greater than, that second one's supposed to be a 7. I assume you didn't flip the sign correctly?
I didn't flip the sign, you're right.
Okay, so we want, and we're going to add the or to this. We want the numbers that are greater than 7 or the numbers that are less than or equal to 3. So on a number line, and I'm going to pick up Miss Young's cheating ways, there's 7 or greater. That's supposed to be a 7. Last year, I guess it was the year before, I wrote a 4 and it looked like chicken foot. So it was really bad. So anyway, when it's greater than, strictly greater than or strictly less than, as you said this earlier, we fill it with we draw it with an open circle. And I like to shade it really heavy, but sometimes I do it a little bit above the line so I can emphasize, because I got bifocals. Like right now, Miss Young looks a whole lot prettier. But
wow. Wow.
Okay. And so that's what my part of the graph looks like. And her part of the graph, hers is less than or equal to. When that's less than, you get to fill in that circle. Okay. So she's got to fill in a circle there. And she wants all the numbers less than 3. So they go that way or whatever way. Yeah, that way. And since this is or, either one of those is fine. Anything that's in the pink part or the purple part, that's going to satisfy one or the other. It's not going to satisfy both simultaneously, but any one of those numbers in those 2 parts would satisfy this inequality.
And it's not abnormal to see this on the ACT. And one of the things they'll do on the ACT is they might shade between the numbers instead of making them go away from each other. So notice that if it's greater than 7, it's pointing to the right. And if it's less than 7, it's pointing to the left. The arrows on your graph will match the arrows in the inequalities. Yeah.
So moving on, now when we have an and situation, well, Ray, that's no fair. You have an easy one on your side.
So anytime you have a compound inequality like we're showing you right now, there really are 2 problems to solve and then a decision to make at the end of that problem of like, where is the solution set falling? So first thing that you're going to do in a problem like this is simply solve each individual inequality and then make a decision about like, what's the graph going to look like? Where are the answers going to fall?
Okay, and so I ended up with, this is our, let me move my screen around here. Is that our answer? X is less than 5 and X is greater than -4. So I need to satisfy both of these. So you want to do our number line thing again?
Yep. So we're looking for only numbers that are at the same time less than 5 and greater than, or less than or equal to 5 and greater than -4. So for example, if I were to pick the number -27 and ask if it was an answer, well, -27 is less than 5, but it's not greater than -4, so that couldn't possibly be an answer to this problem.
So what I just drew is the answer, the graph that represents X is less than or equal to 5. Now Ms. Young is going to draw the solution that represents X is greater than -4. Now we needed to be on both of these things that we drew, and the only place that happens is where the 2 overlap. So how do we actually present this on a quiz or a test? Or if I, what I would expect you to do? Do I need you to erase it because I know somebody's going to use pen? Oh, my heart is hurting. You could highlight it. You did the highlighter. You could go above it and draw an open circle to here and fill it in. Do it above the line, or you could just scratch it out and do it again. But one way like that. Get you a crayon, whatever. But that piece between -4, the open circle at -4, and the closed circle open circle, other way around. Whatever. I can't do it.
Oh my gosh.
Left, right thing is killing me. It's backwards. I'm looking at it.
Yes. Let's say we ask the question, is 5 a solution to this? So is 5 a solution to this, Mr. Bobby?
5 is indeed less than or equal to 5, so I am okay on my side.
And it is greater than -4, so I'm okay on my side. What about 0? Is 0 a solution to this?
0 works for me.
0 works for me as well. It is greater than -4. What about -4?
Hey, -4 is okay by me. I'm cool.
I'm not okay now because -4 is not greater than -4. It's equal to it. So that open circle is really important there because it's telling you that it's not included in this solution set. So kind of an important point there.
Yeah.
I think we got one more for you here.
All right. Oh, wait, I really didn't like that I had a line there, and I'm going to be OCD about it, but all right, whatever. That really was an open circle. Okay. I think, yeah, we got one more to do, and we've been yammering, and they're like yawning, but that's okay. We sound like Mickey Mouse. What if we got a three-headed inequality? Well, what was the rule with equation? What thou doeth unto one side of the equation, thou must doeth unto the other. Well, this has three-headed. This is three sides. Well, that just, we're going to extend it. Whatever I do to one side, I got to do to all sides. So I'm going to subtract 1, except I'm going to do it on the right page. And I'm going to grab my pen. So I'm going to subtract 1, and subtract 1. That's going to give me -4 is less than 2x is what, less than 2. And then I'm going to divide everything by 2. So I get -2 is less than x is less than or equal to 1. And I can draw my number line and do it. If that 2 in front of the x had been negative, what would have happened?
Both signs flip.
Both signs flip. So you do what you did to one, you do the other, so that you do a double flipperino. Okay?
Double flipperino.
And so if you want to draw the number line, or should I?
I think we're good. I think it looks similar to the last number line. We kind of talked through it. I think that's probably, I think y'all are brilliant, beautiful, lovely, wonderful human beings who understand number lines.
All right. I'm happy with that too. So we'll move on. The last thing, there's some practice problems for you to look at. You'll need to go on to Google Classroom and see if there's a quiz or something else you need to complete for this lesson. But otherwise, I think we're happy and content.
Yep. Good luck, guys. Make sure you practice. If you run into any questions, you can email us or send us a message over Google Classroom or hit us up on Zoom.
Bye-bye, y'all.